Here's a solution for Rockswold problem 6.1.67. The problem is to factor this polynomial. It's degree 3, and that's going to limit our options a little bit. But even with polynomials of degree 3, the first thing you should do is think about factoring out common factors. Looking at all of these coefficients, they're all divisible by 5, so let's start by factoring out the factor of 5. So let's pull the 5 over here. That's going to leave behind x cubed plus, let's see, 35 is 7 times 5, so x cubed plus 7x squared plus x plus 7. Okay, now this 5 over here, that's going to be a spectator from now on. We just need to factor the remaining polynomial that's inside the parentheses here. So looking at this polynomial, there aren't any common factors anymore. And since there are 4 terms, really the only trick we have available is to use our grouping trick. So it looks like these first 2 terms have something in common, so let's group those. And these second 2 terms, well, they don't seem to have much in common, but they're sort of left over, so let's make them a group. Okay? Now for each group, let's see what the common factor is. In this group, the common factor is x squared. And in this group, again, not really a common factor. I guess you could say the common factor is 1, but we just won't change this group at all, really. Okay, so let's factor out the common factor in this first group. We get 5 times. So this first group is x squared times x plus 7. And the second group is 1 times x plus 7. Or you could just leave it as x plus 7. Okay, now the second step to this grouping trick is to see if the stuff that's left over after you factor out the common factors from each group, these bits I've underlined, see if they're the same. And in this case, they are the same. They're both x plus 7, and that means this x plus 7 is a common factor, and we can factor it out over to here. So that's going to give us, again, the 5 is a spectator at this point. The x plus 7 we're factoring out. And what's left over? Well, there's an x squared from this part. And from this part over here, there's a 1 that's left over. So now we have 5 times x squared plus 1 times x plus 7. The 5 is as factored as it's going to get. It's prime. The x plus 7 doesn't factor anymore. X squared plus 1, since it's quadratic, we might wonder if it factors, but it's a sum of squares. X squared plus 1, there's no way you can factor this. If you try like this, and then try to figure out what numbers go here and here, you'll find that there aren't any numbers that work that give you x squared plus 1 when you multiply this back out. That means this factor here, x squared plus 1, is actually prime, and so the whole thing is as factored as it's going to get, and so we're done. If you're doing this problem online, your numbers might be different, but the ideas will be the same.